these flat parts inside this noisy time series. So these little bumps here are noise, and this big jump here ends up being a change point in which we're inferring that the underlying process that generates the edges has shifted regimes, that the norm, if you will, of what defines whether edges exist or not has shifted in some way. So we're trying to essentially infer what those norms are as they change over time, if, how, and when they change. So our solution here is going to be to use the fact that we've already built this probabilistic structure, this probabilistic framework. We're just going to take classic time series analysis techniques for change point detection, which use probabilistic models, and replace the thing that generates the value that they care about, which is some scalar or vector value thing, with our piece that generates a network, and then use the same tools. The bad news is that you can't make pretty pictures like this. But you can make pictures like this, which are a little bit, you can kind of understand what's going on there. You see that the pattern of the pink and the blue here is different from over here. And that's essentially what we're trying to detect, is when do those patterns change. OK, so here's how we're going to do it. We're going to have our generative model, so probability of some graph given some parameters. And we're going to apply it to a sliding window. That's going to allow us to detect these non-stationary shifts over time. So that means that given some window, we're going to break it up into pieces. There's going to be the part A and the part B. And the question we want to ask is, are the parameters that define the model that generate these edges different from the parameters of the model that generate these? If those two things are different, then we say a change point occurred between those two. If we can statistically show that theta of A and theta of B are not different, then we say there's no change point there. And then we slide the window forward one more step and repeat. OK. So we're going to use some pretty fancy techniques here to do this. We're going to use a hierarchical block model. So this is a model in which blocks can have blocks inside